Today's topic is refraction of light. So, let's start off by reviewing what is light. We've previously mentioned that light is a portion from the EM spectrum that is visible to the naked human eye. So, if we look onto the side, the visible light region has wavelengths ranging in between 380 nanometers and 700 nanometers, with the following colors as red, orange, yellow, green, blue, indigo, and violet. And when we mix all of these colors, we come up with the white light. So basically, the white light is a mixture of all the wavelengths of the visible spectrum. Moving on to the speed of light, it is very important in today's lesson. And you're usually expected to have this memorized because it's rarely mentioned on tests, so you just have to know it. So the speed of light in vacuum is 3 times 10 to the power of 8 meters per second. And again, only in vacuum, because the speed of light changes when the medium is changed. So, refraction of light. If we look onto the picture here, we can see that the pencil looks broken inside this glass of water. And why is that? That's because of the refraction. What's refraction? It's the bending of a wave due to a change in medium. So basically, the light was traveling through the air in the first half of the cup, then started traveling through water, which is a different substance. So basically, there was a change in the media that the light was traveling through. So the light bends, causing this broken image that we see. Then, the amount of bending depends on the indices of refraction in the two media and is described quantitatively by Snell's law. We will be explaining Snell's law in detail in a second, but first, what is the index of refraction? It is defined as the speed of light in vacuum divided by the speed of light in the medium. So, N equals C over V. Snell's law of refraction, a law stating that the ratio of the sines of the angle of incidence and refraction of a wave are constant when it passes between two given media. So N1 times sine theta 1 equals N2 times sine theta 2. Or N1 over N2 equals sine theta 1 over sine theta 2. What is N1? It's the index of refraction of the first substance that the light travels through. So basically, the index of refraction of the first medium. Then theta 1 is the angle of incidence. Then N2 is the index of refraction of the second substance that the light travels through. Then theta 2 is the angle of refraction. Let's try solving this problem here. The speed of light in a piece of crown glass is 2 times 10 to the power of 8 meters per second. What is the index of refraction of the crown glass? The formula is N equals C over V. We should already know the speed of light in vacuum, which is 3 times 10 to the power of 8, and we have V. So 3 times 10 to the power of 8 over 2 times 10 to the power of 8, we get 1.5. So the crown glass has an index of refraction of 1.5. And we're done with today's video.